f of x sub 0, that's this base, plus f of x sub 1, that's this. That gives us the area of that trapezoid. So then when I do the next trapezoid, that's the first trapezoid. When I do the next trapezoid, I need f of x sub 1 again, right, for the new base, plus x sub 2. So that's why there's an extra one there, and then there's one, and then where's this to? Oh, because the third trapezoid, I have to use this base, and then this one. So I use this one twice again. And then when I find the fourth trapezoid, I have to find this basing, and I get to use that, and this one. And then when I find the fifth trapezoid, I have to use this base again, and the last one only once. So that's why all of these are multiplied by 2 in the inside of the formula, but the first and the last are only multiplied by 1, because it's only used once for the first trapezoid, and this is only used once for the last trapezoid. But all the ones in between are used twice to find the areas of 2 separate trapezoids. Okay? So I'm hoping that you understand that that's a mistake that students tend to make. They do one of 2 things. They either forget to put it in there, actually one of 3 things. They forget to put it in there at all, or they put it in all of them, or I've seen some, and this breaks my little heart, they cancel out this 2, they think with all these 2's in here. No. You can't do that. You would only be able to do that if there was a 2 multiplied by all of them. But since the first and last are forgotten, we don't do that. Okay, so here's the formula. It is something that needs to be memorized. And now we're going to move on and do an example using this formula just to show you what it means. Okay? If you have any questions, I'd be more than happy to answer them when I see you on Wednesday. Or you can stop by my office and see it. I am here today. But, so just stop by and see me, or wait till Wednesday. But I'm hoping that you'll be able to get this formula and understand how to apply it in this first example. We're going to use the trapezoidal rule, as it states, to estimate the area under the curve for each function. So I'm going to do the first one with you, and then the rest are going to be up to you. Now if you look, there's also a graph here. After this video, you're going to be doing some work with some functions that do not have graphs. So you're going to have to be able to figure all this out. So if you look at this, here are my trapezoids. 1, 2, 3, 4, 5. We're finding it from 0 to 1. And that's the one thing I will do for the rest of the ditto, is 0 to 1 is where we're finding the area of that. Okay, so we're not including this right now. We're not including that. Okay? Now if you look, each width is the exact same, or the height of this trapezoid. Looks like it's, these counting on 0.1, so this looks like it's 0.2 right here. And that's 0.4. But how would you get that if you didn't have a picture? You would just do b minus a over n, not 2n. 2n doesn't come into play until we actually apply the trapezoidal rule. So if we wanted to do that, it would be 1 minus 0 over how many trapezoids? 1, 2, 3, 4, 5 trapezoids. So we have 1/5 as our delta x, if you will, or our height. So now let's apply the trapezoidal rule. b minus a over 2n f of x sub 0 plus 2 times f of x sub 1 plus ... 2 times f of x sub n minus 1 sub n minus 1 plus f of x sub n. And now we're going to actually plug in these values. We know that b is 1 because it's right here, minus 0 right there, over 2 times 5 because that's how many trapezoids we have. Now what is f of x sub 0? We know f of x sub 0 is right here. It's our first guy. But what is f of x sub 0? Well, we take 0, we plug it into our function for x. And when I do that, I get negative 0 squared plus 2. I get 2 plus 2 times f of x sub 1. Well, what is x sub 1? X sub 1 is 0.2. That's right here. We found that by counting by 1/5, or 0.2. I should write that, 0.2. So that's where that is. That's x sub 1. What is f of x sub 1? Well, I plug it into x. All right. So when I plug in 0.2 in there, I square it. Now it's not negative 0.2 squared. It's just the negatives on the outside here. So I get a negative value when I do that. And I add to 2, I should get 1.96. And that makes sense if you look at the graph. It's about 1.96 right there. You can use your calculator, calculate that. Plus 2 times the next one. This is 0.4. So we're evaluating at 0.4. I plug it into there. Okay. And when I do that, I should get 1.84. I'm doing this all in my head, so I'm hoping I'm not making any mistakes, and I shouldn't be. I'm at home doing this. So then we go to the next one, which is right here, and that's 0.6. So we would plug 0.6 if we didn't have a picture. Well, even if with the picture, it's hard to sell. We put it in there, we square it, we add 2. It's negative each time with that. And I believe if I did that correctly, it's 2 times 1.64 for that one. And then we have our next one, which is 0.8. And I'm going to go down to the next line. So 2 times 0.8, square it. Okay. Get 0.64, negative 0.64 plus 2. You get 1.36. And then our very last one right here, 1. We don't multiply it by 2, remember, because we're only using that base once. And I get 1 squared. It's negative 1 now, plus 2, so it's 1. All right. Now we are going to, we have to calculate all that. So we're going to use our calculator. I expect you to be able to use your calculator to do this. And when we do calculate all that, we just go right into our home screen, clear it all out, put the large screen up there, and you can see that we can do this, okay? And what I do is I'll do 1/10, sorry about that, 1 divided by 10. We know that that's that, okay, times your second answer times, and then the rest is in there, okay, in the parentheses. So you do 2, sorry for that, plus 2 times 1.96 plus 2 times 1 point, what was the next one? 84. .84, and then we have 1.64, and then we have plus. And if you notice, I don't mind that I'm taking some time here to do this, because I'm assuming that you're doing the same thing and it's taking you a little bit of time. Plus 1, and then close those parentheses, and we should, when we get that, get an approximation under the curve of 1.66. 1.66. Okay, that's the approximation under the curve when I do that. So it really should not be equals, even though it is equals 1.66. But that is the approximate area under that curve between 0 and 1. All right, and that's using the trapezoidal rule. So again, b minus a divided by n gives us our increments of what we're going to do. These are our values of our height that we're going to keep going. That's what we know what to plug in. I still don't, a lot of people use b minus a over 2n. No, remember the 2 comes from the 1/2 b1 plus b2 times the height. Okay, that comes from that formula. So you have 2 that you're now going to try on your own with picture. The video is pretty much done at this point. What I'm going to do is I'm going to pause. You can pause it, and when you come back up, what you'll do is you'll be able to just check your answers, and you'll be good to go. All right. So let's go and let me just show you the intervals. Here again is 0. You're going to find the area from 0 to 1 here. Now don't get upset that this is looks like a triangle, not a trapezoid. All right, I'm just going to point out one thing to you. So listen carefully, put on your thinking caps, turn up the hearing aid, whatever it is. You know the area of a triangle. What is the area of a triangle? It's 1/2 base times height. Okay, well, what's the area of the trapezoid? 1/2 b1 plus b2 times h. Now this is the cool thing and what I love about math. This base of this trapezoid, if you want to call it that, what is that base? This base, this parallel side is 0. So it's really 1/2 0 plus base 2, which is really just 1/2 base times height. So it doesn't matter. It always throws students and go, oh my gosh, it's not a trapezoid, we're using the trapezoid rule. It's a trapezoid with one base equaling 0. So don't let that bug you. All right. So I'm going to erase all this. All right. And go to the next one. This one is from 1, I'm sorry, to 3. Okay, so that's the interval. 1 to 3, you're approximating the area under that curve. All right. So what we're going to do is, instead of pausing the video, we're going to stop the video right now. And what I'll do is I'll include the 2 answers on the plans to check, and then whoever's in there with the class can check as 2 volunteers. We'll have 2 volunteers come on and put these up there when you're done. So a volunteer for number 2 can come up to the board and we can all verify our answers, and a volunteer for number 3 will come up to the board. But we'll give you a few minutes to work on it first. Then the next part of this process is going to be for you to do, I think there's like 8 problems, I don't remember exactly, that the function is given and the interval, but no picture. So you're not going to have anything to compare it to, and you'll do it. And then eventually we're going to do some things with some tables as well. Okay? So I hope you enjoyed this video. I hope you are able to apply that trapezoidal rule. And let's go over that trapezoidal rule one more time, just in closure. What is it? The area equals b minus a over 2n times f of x sub 0 plus 2 times f of x sub 1 plus 2 times f of x sub 2. And how many times do we do that? We do it all the way. 2 times f of x sub n minus 1 plus f of x sub n. Remember not to multiply the first and the last by 2, but all the ones in between. All right? And I'll see you around. Johnstone, out.